Welcome back, students, and I hope you are doing very well. Today I'm going again to give you another explanation for the project that you have in the course of water supply and sewerage. As you know, as I sent you a layer, a map, a project, it's required from you to design for a certain zone, its water work pipelines and its sewer work line. So first of all, let's check with the map that we have. Here's the AutoCAD version that I sent you in 3 versions, so you can open it in any AutoCAD that you have. Here's the layout of the project. It's a city, and we have 1, 2, 3, 4, 5, 6 zones. So you are allowed to select one of the zones, and okay. So first of all, I want you to see first of all, for beginning with any project that you have, usually the file that you will receive, there's many architectural work on it. There is many survey work on it, so and they are all working in a certain layer, their own layers. Here's the layers. You can see from the home, you can see from the layers that you have. By the way, I made a layer for you, showing to you which work you are here, so the zones that you are going to work. And here's the all layers that we have. For example, we have a layer for only the streets, we have only the layer for the points. The points means the survey point that we have for the grass, we have for the architecture, and also we have for the border, we have the contour lines. Here's the contour lines, the most important thing that we have, and so on. So I advise you to first of all do a new layer for your work as a group, and do it for, let me say, for water work, a layer, and do another layer for the sewer work. Let's start with the first one, which is the water work. So I'm going to create a new layer. I should go to the layer properties, and the layer properties, you can see here's the current layer is AOIS. Now I want you to make a new layer. Here's the new layer. You can stop here and do a layer. I will say, for example, my zone is zone D. Zone D, let me say water. Okay, and I will make another layer for zone D, sewer. Now I want to start with the zone D, water, and I will say, okay, make this is the current layer. Okay, set the current layer. Now I am with the current layer, and I can change some properties of this layer. For example, I want to make it in green, in blue. Yeah. So I look at this one. Now you are in the layer, the new layer. The new layer, it means that you have layer D. And I want now, if I want to remove the others, let me say my group is here, so I want to check with this zone. So I will go with this zone, and this is zone D. So I know that this is all my boundary of the work, so it's not need to have the other zones. I can say okay, I will just turn off the UIS okay, I will just turn off the previous layer of the zones. Here's turn off. Okay, now here's what the border of my work. Okay, so I have houses, block 1, block 2, block, and 3 block, and so on. So you can see from these are the points that I have from the survey. This is 1.1. By the way, previously I designed something here. The total network, I want to divide the total network in. Okay, I want to turn off the total network. You can see here's the points that I have. From the points that it's clearly appeared that here's some points that I have. So the water, look at this one. Here's the elevation. So the elevation at this point is 105, and the elevation of this point is 101. So what I should do, I will propose that I have for the highest elevation in this region, I have a tank. I will propose there is a tank here, and I will draw this tank. I will assume there is a tank, and I will say I will draw a point, and I will say this is a tank. Okay, okay, so I will say assume that there is a tank here, and I will make this tank sorry. Okay, I will assume that there is a tank here. Okay, this is the tank, and I will write here I said this is a tank. Okay, this is just to be aware that this is, I'm not going to do anything with the tank. I'm just I just want to to have this tank, and the next step is to have to draw a pipe from this tank. And by the way, this is will be the elevated tank, and the elevated tank will be for example, the level of the elevated tank will be I will assume that I have 15 meters from the bottom, the head of the water in the tank, and so on. Okay. Now I will draw a line. Here's the line. I have to draw modify. Yeah, so start a line, or polyline will be better. I'll start drawing the line from here till this point, then go this way. Okay. Again, we want to draw a line. To go to this way, and again I want to draw another line in this way. Okay. Now assume that I have only these two blocks. So what should I do? By the way, this is not to be linked together. There should be a pipe here. What I should do, this will represent the network of the water in this pipe. As you remember that we said we have this layer is for the water only. So what I should do, first of all, I have to name these pipes. So I will say will be pipe 1 and this will be pipe 2, or it will be better if you name them as A, B, C, D, and so on. So it will be better to name them. For example, I want to name this one as an A. Okay, I will name it as an A. Oh, sorry. This will be A, and I will copy it. it will take from the beginning somehow a little bit time, but it's necessary for having a very good design. So let's start numbering. This is A, and A here will be B, this is B, and we have C, this is become D, okay. And so on. So A, B, C, D, E, F. This is also become E. And the last thing that I have, F. Now let's say this is my zone. You shall continue with numbering all the pipes. So I have a tank, and this is the tank, and this tank can send water. We will send water to these parts. Now it's the time to start, how to start building, how to start taking the flow and designing this network. I will show you how to do this one. Project. Okay, so to start the design, you need the followings. Okay, so as there is in the AutoCAD file, here's the folders, here's the blocks that I have, and here's the tank. So here's the A, B, C, D, E, F. So what is required for you is to first of all calculate or designing. Designing, it means you have to find the proper pipe diameters and check for the velocity and the residual pressure at the end of the node. It means you have to find the velocity in the pipes, and you have to check the velocity, and the velocity usually it should not be less than 0.6 meter per second, and it will not be more than 1.5 meter per second, and the pressure at the dead points should not be less than let me say, it should not be more than 3. It should be it should be less than maybe 2 bars, and we may have 0.5 bars. Okay, so usually the pressure should be between them and this one. Now I used a tank. This is the tank, and I say this tank is of 15 meters height, so the edge at the tank is equal to 15 meters, and properly it will be I will assume, which is equal to head at point A. Now to find the head at B, I should find this pipe, flow in this pipe, because the head at B will become the head at B is equal to head at A minus the head loss from A to B, and this head loss is equal to, can be found from the FL over D V square over 2G. Now is the length, is the, what are these, the F is depending on the pipe that I am using, most likely it's 0.021, and L is the length of the pipe, the length of the pipe that I have. I can, and this is could be founded from the AutoCAD. How to do that? You have to go to the dimensions. Sorry, you have to go to the dimensions. Here's the dimension, and check, be careful, you have to check which dimensions that you want to be. Here's the dimensions. Okay, sorry. Yeah, I will go with the inclined dimensions. Here's the inclined dimensions, align dimensions. So I want to see from dimension from A to B. You can do that one, or you can just pick sorry, you can just pick this line, and you can say, or sorry, you can say I want to draw to find the dimension, and you can just enter to find, yeah. So here's the dimension of AB, and be aware these are in meters because the scale are in the meters. So 46.67 is the dimension of this pipeline from A to B. Now back to the 46, so here was about 46 meters. The D is the diameter. You have to assume a diameter. Assume a diameter for the this pipe, and usually it will start from 2.5 inch to 3.5 inch, 3 inch. So I think it's better to start with 3 inch, 3 inch pipe diameter, and what is left, 2G is 2 times 9.81. What's left for us is the velocity. How to find the velocity in this pipe? You have the diameter, you assume this is 3 inch. Now the velocity is equal to Q over A. What is the Q? What is the demand of water for this city? So we have to find how much is this pipe should be deliver water for this area. Now you have to suppose that how many houses is there, how many number of the houses in this block, because these are should be supplied with the water for what. Now number of the houses times 6 person per houses, this is the total number, times 250 liter per capita per day, this is the average. This is called the average demand, and we should find the maximum demand. The maximum demand is equal to average demand, Q average, times the peak factor. The peak factor for monthly, it's usually I think it's 1.48. So I will find the monthly, peak monthly, this is the peak demand. Now is it that enough? No, because we have to add the Q for fire to this one. So the Q for fire is could be 120 square root of P 1 minus 0.01 square root of P. Now what is the P? Is the population in this area, and this is will be in gallon per minute. So in addition we will have to add them to this pipe, and this is will be easy to find this one. Then after that you can have the Q, and from the Q I have the diameter. I will check with the velocity. Now sometimes we have for small area the velocity will not check, so you have to make a smaller pipe, but the municipality or the policy is not letting you to have less than 2.5 inch, so you will say it's okay for having velocity less than this one. But the most important thing is to find the head losses. Now after that you have a velocity, then you will check for the velocity for the head loss in this pipe. Now you can draw a line, a table. For example, pipe, I have pipe AB, the length of the pipe and the assumed diameter. Now the Q, which is equal to Q maximum plus maximum demand plus the fire, and now you have to find the velocity, which is equal to Q divided by area of the pipe. Assume that. Now find the head loss. The head loss, which is equal to F all over D V square over 2G. And then go to the next pipe BC and CD and so on. Then after that you have to locate, you have to say to find, or let me say you can draw these results on the map that you have. You have to go back to this one. You can say okay, I have this pipe, and this pipe will be equal, its diameter will be okay. So you have to draw all the pipes here, and then by the way, the head in this pipe, the head at point A and the head loss from A to B, the length is here. So how to find the head at B? Just the head at A minus the head loss will give you at this one. Now I'm done with the water work. I have to go. And by the way, you have to put the valves here. I want a valve here, and I want a valve here, and valve here, and valve here. That will be you have to locate them. Okay, I'm going when you are done with the water, I prefer to lock the zone or to hide this one and go to the zone that we have these sewers, and make this one current and hide the previous zone. For not here's for the water, I will hide this one. Okay, and then I work with the zone of the sewer for that zone. To do that, I have let me stop here. For the part of the sewer, which is very important to know where you have to start with, the first point is to start with I'm going to put the location of the manholes here. Now to do that, I'm going to just draw for example here's the manhole. I will draw for example, and make sure we are working in the sewer layer. And best to use zoom window, and Okay, and if you want first to just hide this layer, this is profile line, I will just hide this profile line there. Okay, now to start the work, I will start. Here's my block. I advise you to start putting the manholes. First of all, draw a circle, and here's I will start. Here's my first manhole. Now after this, I advise you to copy, and the option of copy in AutoCAD, it's very easy. You have to go with the modify and copy, and I will copy from this point, and okay, I will do another one here, and it's better to make it in center line, and there is another one here, and there will be another one here. Yeah, starting with this manhole, and also there will be another manhole here. Yeah, so to put another manhole here and here. Sometimes you need, if the length of the pipes are in this two, maybe we need to put another one. Just you have to check. I think it is, let me check the distance between manhole to another manhole. We don't want to be more spaces between the manholes, so I want to check the dimensions between. Let me check this dimension. Yeah, so I will check the distance from this point to this manhole. Yeah, it's 46. I prefer to not have more than 25 meters, and usually you have been allocated. So for this kind of two manholes, I will add another manhole in between. So I will just copy this one, and yeah, put it another one here. In the middle, it will be better. I think there is another one. This needs another manhole, and this needs another manhole. I think I made you have to be precisely in the location, because the location is very important. And during the work with the AutoCAD, I prefer you to turn off the snap, and this will be F3, so it can work easier. Also we have this one, move from here to there. Now the first of all, these are the manholes, so you have to number them. The direction is the flow is very important. You have to check the direction. As we know that we have the layer, or which is the called profile or the plan. Here's the contour line, and the contour line, you can check the contour line. I will use a layer. Yeah, this is the layer of the contour lines. you can check easily. And you have the dimensions. Yeah, so for example, this manholes will become between 170, 107.5, 176, 106, and this will be 101.5. So the direction will be from the highest level to the lowest level, but because we want to move from the high elevation to the lower. So here's the manholes will come from here, and this will be the direction. And again, the direction now it's clear to me, and we'll connect between the manholes with pipes. Okay, and then go to the another pipe, manhole, go here, and we have to go with the same pipe, the same manhole. And you have to be aware for the dimensions and how to make, so you need to be quite. Now this is the manholes, and you have to do for the other blocks. We have to add again, and the main thing that we have, this is the manholes 2, and here's the third one. Okay, I have to draw a pipeline here. Okay, now I am done with the profiles, and you have to number the manholes. For example, this will be manhole number 1. It's very important to start with the manholes numbers. Sorry. Now what I'm going to do, I have just to go to make a copy to, I prefer you all and just near this project. First of all, you have to put the numbers and then go and number them sequentially. Okay. Now what I have to do is to renumber. I'm just going to renumber the values. Okay, so after numbering the whole so we should make this one as equal to 2. And this should be 3. And this way we have to have a manhole number 4. And 5. And 6 and 7. Okay, and you have to continue till you are done with the zone that you have. Now the question is how to start. So let's draw a sketch for the work. It was look like this. Was the block. Was the nether block. And I start with this manhole, and was manhole number 2. This is manhole number 3. And there was another manhole here, 1 2 3 and 1 2 3. So the direction is very important, and there is a manhole here. Okay, this is the second. And so on. So let's say that we have done with the manhole. So what should I do? So first of all, starting with manhole number 1, sorry about this one, manhole number 1, manhole number 2, manhole number 3, and manhole number 4. So what we should start, we have to start with the manhole. So first manhole, we have to have its dimensions, bed level, and you have to draw a profile like this. And this profile it will be look like this, and you will say this is manhole number, this is stations. You have to allocate the stations for this one. Let me say I will start with 0. This is 150 meters. This is 75 meters. And this is 100 meters and 125 meters, and this was 0.025 meters, and so on. Now this is the first thing that we have it. Our first manhole is located here, so I will just draw a line. I will say this is the manhole. This is manhole number 1, Maybe manhole number 2 is located in 30. Maybe here's manhole number 2. I will check this one with the location of manhole number 2. How to do that? I will find its location. So how much is the distance between this? I want to find the distance between this point and this point. It's 17.8 meter. So 17.8 meters you have to allocate 17. So it will be 17.8. This is 25. So this is manhole number 2. It's 17. Now it's, if this was 0, this is will be 17.80. Now I have to mention bed level. This is for bed level. What does that means? It means that if this is the natural ground level and this is the manhole, so the starting manhole should have at least 1.5 meter. Okay, so this is the depth of the first manhole. This is called the invert level. So the invert level of this bed level, you have to allocate this one, and you will start. Okay, the first one, the first invert level is 1.5. Now 1.5 is the depth, so you have to have the level here. Let me say this was 106. If the level of the ground, what natural ground level is 106, so how much it will be the bed invert level? Usually you have to say here's, okay, the level here will become 106 minus 1.5, so it's 104.5. so the invert level of 0.1 of manhole 1, it could be 104.5. now I have to do the same for invert level at manhole 2. So the invert level at manhole 2 will depend on how much is the depth of the pipe that I will send from A to B. So let me say this is manhole number 2. So look at, maybe we have a different surface level, but the pipe will go from here to there by a slope. So the pipe is going from here to there by a slope. This is the slope of the sewer, and it's better to use the minimum or a slope. We have a minimum slope. The minimum slope, we can get the minimum slope for from the pipe profile, from the catalog of the pipes, or you can go with the profile, or let me see, the level, the slope of the natural ground level, if it is better. Okay, because I will do a small cut, the same cut. If you are going with the slope of the natural ground level, it's okay, but this is also should be less than the minimum, greater than minimum slope. So I prefer to go with the minimum slope. The minimum slope for the pipe, you have to find this pipe diameter, and from the pipe diameter you have to select, you have to go to the minimum slope. Okay, here's the diameter, here's the pipe that we are using in the design. So I have to go with the minimum pipe slopes. Now for the pipe slopes, minimum pipe slopes, here is minimum pipe slopes. Yeah, this is will give you the sorry, not this one. Okay, Here's the minimum slope that I have. So usually we are starting with a pipe of 8" or 200 millimeters, so the minimum slope is 0.01. so at least you will have, the pipe should have a 0.01 percentage. So this is 0.01, this is the Manning, it's 0.96 percentage. So 1% is a very good in this one, or more based on, but it's sufficient to have 0.96%. so assume that we are using 0.96 or 1%. Back to what we have here, 1%. so I have the slope of this y based on the minimum slope, which is 1%. 1%. This is will be valid for a pipe of 200 millimeters. So assuming that I am starting with a pipe of 200 millimeters. Now based on this one, and I have the distance from this pipe to this one, I have I think it's 17 point, the distance between this manhole and this manhole number 1 and manhole number 2, it was 17 point, I think, something. Yeah, and this is the manhole. (17.8). So I have to have here 17.8. So 17.8. So 17.8 I have multiplied by 0.1 percentage. So 17.8 the length times 1% will give you 0.178 meter. So the bed level of this manhole, this is the invert level of this manhole, is equal to 100 this is 104.5 minus the 0.178, and so on for the other manholes. Now I have to go with the pipes, and I have to assume the sewer diameters based on this one, and after that I have to check. I have to check for, I will say, I have to draw a line. I will say manholes pipe from manhole number to manhole number. So pipe 1, sewer 1, from manhole number 1 to manhole number 2. The length was 17.8 meter. Okay, now the diameter was 200 millimeter. Now I have to find the velocity. First of all, I have to assume the depth of the let me say I have to find the Q for that's flowing this pipe. So what we have here in this pipe, I will assume that, yeah, the calculation of the flow is very important in this design. Yeah, so I have to find, I will assume that, okay, this area, this pipe and this pipe, they are holding the sewer, the flow of this whole area. So I have to calculate the houses here and the houses here. So the Q from manhole number 1 to manhole number 2, which is the same Q for 2 to 3, will be calculated in this way. So the Q from pipe sewer number 1 is first of all we have to find the Q from municipalities, or this is will be equal, we have the Q average or the flow, the demand, the water demand, water consumption times an equation. We have an equation for this one, and we will find how much is the flow. This is the average, and we have to find the peak factor. The peak factor, we have two options as it's given to you from the calculations from the literature review that we have it. I think it's in chapter 5. So we have to calculate the domestic, as I say, domestic flow, which is the assumption 90% of the demand of the water, which is 250, times the number of the population times the 250. This is will give you an average demand at the average flow. Then after the average flow, I have to find the peak flow, which is equal to the factor, which is here 18 plus the population and the square root plus 4 or 5 under this one. So which one, whatever of these two values giving you more maximum, so you will take this one and as a peak factor, and you will have to multiply this Q with this one. This is for the maximum Q. So maximum Q will be either from 18 plus square root of P or divided by 4 plus square root of P, or we have to find the other one, which is equal to here's the P 5 over P over 6, or 5 divided by P population over 1 over 6. So whatever one of them giving you maximum, you will take it as a peak factor. Now this is for the demand, or for this is for the flow from the municipal. We have the storm, because I want you to design for combine. So for the combine, you know that the Q is equal to CIA, and the C will be an average area, and you can take it as a 1 for ultimate peak flow, and the I is the intensity of the runoff that we have. I think it was given to you, I think it's 30 millimeter per hour, and the area here is the area of the location that you have. Now I can say the area can be founded from this one. For example, if I want to see the watershed or this area, okay, I can say if I want to calculate the flow, the runoff from this one, so you should calculate the area. The area can be founded from using the AutoCAD. Here's the AutoCAD, the measure, modified, yeah. So you can go to the analyze and use the inquiry, and from the inquiry we have area. This is the area, and you can find an area that you want to have it. For example, if I want to take this area And by the way, this is the only area that we can have them, and I can just enter. It will give you 200. This is 200, 2000. You look at this one, it's 2000 square feet, or 2047. By the way, the units here is in meter, so forget about this inch. It's 2047.73. So it's about 2470 point something. This is meter square, and this will be the Q, and then the total Q is equal to Q plus the storm plus the Q of the wet. Now you have the Q. You have to assume that this is the real Q and the full flow. If I have the, let me say, the d over d, the partial flow was 0.75 or 0.5, for example. So the Q over Q will be how much? We can get the Q over Q from this equation. Yeah, from this equation you can get the Q over Q. So if I assume that the partial flow was, for example, 6%, so d over d, here's the height of the water, so d over d it was 6, then I can get the Q over Q is 0.65. So 0.65, I can say, okay, 0.65 of the and it will equal to 0.65. So the Q full can be, so this Q full is equal to the small q, the calculated one. Let me say this is the Q maximum divided by 0.65. You can get the full flow for this pipe. Now you have this one, and you have the flow, we have the diameter, we have everything. You have to calculate the partial, the velocity, minimum velocity in this pipe. The minimum velocity should be also more than 0.65, and you have to do this for all the rest of the pipes. And I prefer you to put all the data in one profile, and in profiles you have to find for the manholes, manhole 1, manhole 2, manhole 3, and you have to draw the lines between them, and you have to say this is the phi and this is the slope, and then this is the another one, and then another one, and so on. And don't put more than 4 manholes in one profile. Thank you for watching. I hope this was interesting to you, and please do your calculation in a way that it will be easy for me and for you to read it. Thank you very much.